NIST report, NIST, the the federal lab under the Department of Commerce in the U.S., charged with explaining the collapse of the towers in Building 7. Here's some important background. NIST says in their report, other than initiating the fires in World Trade Center 7, the damage from the debris from World Trade Center 1, that's the closest tower, had little effect on initiating the collapse of World Trade Center 7. Agreed. So there's some things, you know, that we agree with them on, actually. As they study this, they say, look, it's not due to the debris. And then how about the diesel fuel? There was diesel fuel stored because there were a huge electrical generator there in the building. In Popular Mechanics article in 2005, they cited this as a probable contributing factor, a major factor in the collapse of Building 7. So, from Popular Mechanics, investigators believe the fire was fed by tanks of diesel fuel. And New York Times article also said the same thing. But in the August 2008 report last year, this notion is also thrown out. However, NIST writes, fuel oil fires did not play a role in the collapse of World Trade Center 7. As they studied this, they rule that out. So it's not due to debris from the tower across the street. It's not due to oil, diesel fuel for the generators. So here's what they blame. They blame it on fire. The challenge was to determine if a fire-induced floor system failure could occur in World Trade Center 7 under an ordinary building contents fire. Again, we see an example of the blinders being on. They're not trying, it should, I think, read, the challenge is to explain the collapse, the rapid and complete and symmetrical collapse of World Trade Center 7 on 9/11. But instead, their challenge is to see if they can get fire-induced floor system failure, if that could explain it. Okay. Oh, dear. So how do they proceed? They used computer modeling. I might say, they admit in the report, they did not look at any steel samples from World Trade Center 7. And what they did then is they use a computer model. It's a black box. Now, I would like to know if they would be willing to release this model, but so far they've been unwilling to. There's a few things in this model that I think are physically questionable. So see what you think, students. Quoting from the report, the steel was assumed in the FDS, this is their model, to be thermally thin. Thus, no thermal conductivity was used. Let's see what that means. It means, okay, so you have you had a straight pin and you heat one end of it, like to get a sliver out. I do that when I have a sliver. I heat one end. Well, pretty soon the end where I'm holding the pin gets very hot. And this is because of thermal conductivity, which means the heat is transported along the steel. Now, a pin is stainless steel, typically, and these beams are steel. But the thermal conductivity is not zero. I've done the experiment with the pin. I know it's not zero. But in the model, they turn it to zero. You see? Now, that helps it to work, of course, but even if you're NIST, you can't throw out the laws of physics. I'm sorry. You know, it just is mind-boggling that they would do this trick. Furthermore, they write in their report, it appeared likely the critical damage state, where this thing started to collapse, occurred between 3.5 and 4 hours. Now, burning office materials, here's a photo inside one of the World Trade Center buildings, typical type office. You know, how do you get these office materials to burn near the critical column, which they claim was affected, for 3.5 to 4 hours, particularly when NIST themselves published earlier data that shows how total heat release rate goes up. You see, it reaches a peak around, what is that, somewhere around 700 seconds, 12 minutes or something. You've burned fires, you've done the experiment. You can assemble all the paper and toner that you want, chairs, tables, you know. These things tend to burn out in half an hour. And you see that rate of heat release tapering off quite rapidly. But no, they want not just half an hour or 50 minutes, they want 3.5 to 4 hours of burning near the critical column. What is there, someone in there pushing all the paper around this critical column, you know, to keep it fed for 3.5 hours? I'm sorry, it just boggles my mind. And yet, that's what they say. Plus they turn the heat conductivity to 0. Well, sure, if you burn a fire under a critical column for 3.5 hours, this office material, and turn the heat transport conductivity to 0, yeah, I can imagine some effects will happen, but it's not physical. You can, like I say here, your computer model will allow you to do any crazy thing, but nature will not. You know, it will not. So we would like to see the model released, and we will plug in realistic values. We'll give it it's well known, it's measured, you know, the heat conductivity for steel, we'll plug that in. It's an easy parameter to fix in their model, and we'll see how long it takes. I don't think it'll ever collapse, though, under that condition. It took them 3.5 hours with the heat conductivity off. The heart of science, students, is independent verification. I hope you know we talk about this repeatedly as scientists. It has to be that other scientists can test what you're claiming, and they can publish papers that challenge you, and then you say, well, do this experiment and you'll see what we mean, and so on. But here, in this case, they're not doing experiments. They didn't even look at the steel from Building 7. They're doing a computer model, which they won't let us look at and adjust the parameters to be physically accurate. There's no independent checking possible. This is the very definition of pseudoscience, bad science, where they make claims and you can't check them. That is bad science. I hope you understand how frustrated I am with NIST. But we already know, again, a little humor to maybe lighten. We already know who did it, don't we? So here's what they might pursue. From what we can gather, it appears a giant red arrow pushed World Trade Center down. I mean, you know, it's as good as their other model, and it doesn't require all this fancy, you know, turning the heat conductivity to 0 and all that. See, okay, you get the idea. All right. Now, the acceleration of the building, Building 7, as it came down. You can see from photographs, this from the actually from the video, frames that at 1 second interval, you can see that the motion of the roof line, okay, it drops a little here and it drops here. I don't care when you start, students, for this. We're talking about acceleration now. Okay, so it's the change, the delta in the motion that counts. It drops a little, and then it drops more, then it drops more, and more. That is accelerated motion, not constant motion. If it's constant, it would drop the same amount, the same distance each second, right? You can see, I hope from these data, that the building is accelerating in its fall. Now, listen to this, please.
This next question comes from Dr. Stephen Jones. NIST discusses the fall time for WTC-7 on page 40 of the summary report, where it's stated, assuming that the descent speed was approximately constant. However, observations by others of the descent speed show that the building is accelerating rather than being at constant speed. So the question is, why did NIST assume that the descent speed was approximately constant?
In the summer of 2008, when NIST came out with their preliminary report on Building 7, we were allowed to ask them questions by email, not in person. We've tried to sit down with them in person. They have declined to meet with me and other scientists in person. But they had this press conference, as you see in this room, where they were fielding questions sent to them by email. So I pointed out in their report, you see it right here in yellow, assuming that the descent speed was approximately constant. This is for World Trade Center 7. Well, you know, this is a very obvious error, okay? It's a junior high school student type of error to assume that the descent is constant when anyone can look at the data, as they're supposed to do, they're charged to do by Congress. You can see that it's accelerating in its descent. And so I sent an email in, and I actually asked 3 questions. This was one of them. And in response to this, by the way, one of the others was, how about this explosive material, this red chips I'll talk about soon. Did you look for explosive residues in the dust? And they basically said, we're not going to look for explosive residues, period. So it's very sad. That's, again, unscientific not to even look. But here's what they came up with in response to my question, and David Chandler asked them a very similar question. We asked them, without talking to each other first, we asked NIST to explain why they would use, why they didn't consider the actual acceleration of World Trade Center 7. So here, and now this is looking at the roof line, and you can see this is now in the final NIST report, where they do agree and they admit that this, looking at the velocity of the roof line as a function of time over 2.25 seconds, it's a straight line. Very close to that. It fits very well to a straight line. And then they actually do the determination of the slope. A physics student could easily take these data, look at the delta V sub y over delta t, and you'll get the acceleration. It's linear on this plot, and you get the acceleration. Here's what NIST wrote in their final report. The slope of the velocity curve is approximately constant between 1.75 and 4 seconds. A good straight line fit to the points in this range allowed estimation of the constant downward acceleration during this time interval. This acceleration, here's the punchline, was 32.2 feet per second squared, 9.81 meters per second squared, equivalent to the acceleration of gravity g. Folks, that's the same as if I took a steel ball and dropped it. Nothing in the way. Okay? That's free fall, and they admit that. This free fall drop continued for approximately 8 stories, 32 meters, 105 feet. That means that this roof was falling for some 32 meters with nothing slowing it down. I'm going to borrow from Frank Legg's paper a minute, this nice little illustration. This is for one of the towers, but the same thing applies at Building 7. If you have a block of floors, including the roof, falling onto columns and concrete, hundreds of thousands of tons of mass, and then this one falling just freely, right? Nothing, somehow we've moved stuff out of the way. We'll talk about that, but you have to, it's not just the support columns, it's also the mass. The mass alone will slow down so that you cannot accelerate at g, which is the acceleration due to gravity. You understand? Students, rest? Okay. So let me ask you, which of these 2 roofs, the one on the left or the one on the right, will fall more slowly? This is not a trick question. The one on the left will fall more slowly. And why is that? Okay, I hear several answers, and I'll help you. Inertia, well, yes, conservation. Something in the way is the easiest way to put it. It boils down to conservation momentum. When a moving mass hits another mass, it slows down. It's conservation of momentum. And the third law will get you the same answer, Newton's third law. There's an upward force applied to something that hits this object with a downward force. There's also an upward force. So obviously, to get free fall, somehow you must have moved hundreds of thousands of tons of material out of the way. Now, fires will burn up paper and desks and so on. Will they burn up concrete? No, not just unlikely. No, the answer is easy. How about steel? Will they vaporize steel? No. So how do you, let's think just for a minute, how do we move thousands of tons of concrete and steel out of the way, or at least get it falling at the same time so that the roof is unimpeded, you see? How do we do that? Explosive. No, it's not magic. NIST report, NIST, the lab, the federal lab under the Department of Commerce in the U.S., charged with explaining the collapse of the towers and Building 7. Here's some important background. NIST says in their report, other than initiating the fires in World Trade Center 7, the damage from the debris from World Trade Center 1, that's the closest tower, had little effect on initiating the collapse of World Trade Center 7. Agreed. So there's some things, you know, that we agree with them on, actually. As they study this, they say, look, it's not due to the debris. And then how about the diesel fuel? There was diesel fuel stored because there were a huge electrical generator there in the building. And same thing. But in the August 2008 report last year, this notion is also thrown out. However, NIST writes, fuel oil fires did not play a role in the collapse of World Trade Center 7. As they studied this, they rule that out. So it's not due to debris from the tower across the street. It's not due to oil, diesel fuel for the generators. So here's what they blame. They blame it on fire. The challenge was to determine if a fire-induced floor system failure could occur in World Trade Center 7 under an ordinary building contents fire. Again, we see an example of the blinders in Popular Mechanics article in 2005. They cited this as a probable contributing factor, a major factor in the collapse of Building 7. So, from Popular Mechanics, investigators believe the fire was fed by tanks of diesel fuel. And the New York Times article also said the